Okay, a quick review. The change in momentum will equal the impulse. M delta V equals Ft, or F delta T, correct? So, the change in momentum. I'm going 60 miles an hour south on Route 18. And I have to take the ramp to go on to 138 west. I've got to slow down to say 20 miles an hour or less, 15, 20 miles an hour, correct? So I'm going to have a change of velocity of 40 miles an hour, right? So the mass of your car times 40, that's how much momentum you're going to lose. Well, wait a second. It took me 20 minutes, 20 seconds to slow down. Well, I bled, let's say the vehicle is 2 kilotons, 2 metric tons. So it would be 2,000 kilograms times 60. That's going to be times 30 meters per second. That's going to be 60,000 momentum units. I'm going to burn off. Let's say I'm slowing down to 10 meters per second. So 20 times 2, that's 40,000. So I was going 60,000 momentum units. I'm going to bleed off 40,000 momentum units in 20 seconds. So 40,000 divided by 20 is what? 40,000 divided by 20 is 2,000 newtons. That's the force. So change in momentum equals force times time. All right. Half the chapter. Change in momentum, define momentum, bouncing, force times time, impulse, half the chapter. The other half of the chapter, confusing. Conservation of momentum. The initial momentum equals the final momentum. Let's say I have 3 things. The Pleasant Valley Sunday, the kids that went out fishing. We had Keith, Nate, and the boat, right? You had Keith, the mass of Keith, the mass of what? Nate. The mass of Nate, the mass of the boat. You had the mass of Keith, the mass of Nate, the mass of the boat. This is the final velocity. This is the initial velocity. All right? We'll do a practice problem, and that'll be good for tomorrow as well. Okay. Let's say that Nate, the mass of Nate is 100 kilograms. Okay? Let's say the mass of Keith, I don't think you can see that. Let's say the mass of Keith equals, pick a number, 50 kilograms. Okay? It's Keith. The mass of the boat equals 200 kilograms. Okay? Now, the speed, the final speed of Nate. I'm not going to tell you the velocity. You're going to have to tell me the velocity. But I'll say that the speed of Nate is going to go off the back of the boat. Okay? And he's going to dive in 8 meters per second. Really fast. There's no way he can do that. But let's say he can. Let's pretend. Okay? 8 meters per second. We are, all I'm telling you is that he's going off the back. All right? And that's, what did I say that was, Nate? Yeah. Okay. And that's Nate. And Keith, he's going to go off the front. Let's say he goes off, 3 meters per second. 3 meters per second. Okay? That's Keith. Yes? Mm-hmm. Okay. Let's say the boat is going from left to right. I'm running out of room here. let me get rid of this. Let's say the boat is going this way, and let's say the boat is, the velocity of the boat, final of the boat equals, I don't know. All right? But let's say the initial velocity of the boat equals 5 meters per second. 5 meters per second. All right? I want to know what the final velocity is of the boat. All right? Shall we review what we did here? Nate has a mass of 100 kilograms. Keith has a mass of 50 kilograms. The boat has a mass of 200 kilograms. Those are not going to change. They're going to be the same. Yes? The boat is going, how far fast did I say? 5 meters per second. That's the boat. 5 meters per second. Nate is going to jump off the back at 8 meters per second. Correct?
Yep.
And Keith is going to jump off the front at 3 meters per second. These are speeds. They are not velocities. Be careful. All right? I want to know the final velocity is of the boat. Try that. I'll be right back. I'll have everything done on the board. See if you can do it. Be great for the quiz tomorrow. Okay? Be right back.